Right, hello everybody. Welcome to my first ever live YouTube stream. My name is Dr. John Wagner. I'm joined with my colleague Andrew O'Brien, who's helping me a little bit with the technology. This is a webinar to introduce and talk about the Aeroqual AQY, a micro monitoring station. So the format for the webinar is going to be me giving you an introduction. We have a PowerPoint presentation, so we'll be flicking back and forth a little bit between the PowerPoint presentation and myself talking. As I said before, this is the first time we've tried YouTube Live, so please be patient with us. It's certainly my first time. If you have any questions, I'm going to try and keep an eye on the YouTube chat, and if I can answer any of your questions during the webinar, then I'll do so. Towards the very end of the presentation, we'll dedicate a time for some questions. My colleague Andrew over there will also keep an eye on the chat. So if you have any really burning questions, please do type them into the chat, and we'll try and devote some time towards the end to answer your questions. So I'll just pop up the first slide and we can talk a little bit about the topics that we'll be discussing during the webinar. So the first slide, we're just going to cover off what measurement parameters the AQY measures. We're going to have a little bit of discussion about the sensor lifetime and what field service requirements are. The power solar installation requirements, a little bit about the software. We won't spend too much time on the software, but we'll talk a little bit about some of the data validation steps that we would encourage you guys to do. We'll talk a little bit about performance validation, which has been done by other parties, third parties. And towards the end of the talk, we're going to reach out to you guys, talk about what you would like to see come into the future for the AQY, both in terms of the measurement parameters and also maybe some of the communication protocols. We will be discussing pricing at the end of the webinar, so hang on for that. I'm sure lots of you will be wanting to know. And then the very last thing we'll be doing is to dedicate some time for questions towards the end. So I hope now knowing what the agenda is, you guys can hold back a little bit from asking too many questions early on. Hopefully we'll cover off all of the topics that you want to have that you're interested in understanding during the webinar. But of course, please do type a question in if you feel as if that I'm not going to cover it off during the webinar. Okay, so flick onto our first slide. So I think it's really good to talk about the AQY in context with some of the other products that many of you may already be familiar with. Our AQM65 is our flagship product. Actually, our AQM65 is having its 10th birthday this year, so we're very proud of that. The AQM65 is a multi-parameter customizable sensor platform. So it can measure ozone, it can measure NO2, SO2, CO, PM10 and PM2.5, H2S, CO2. It's also compatible with a lot of weather stations, anemometers, solar radiation and noise. So many of you may be familiar with the AQM65. A key feature of the AQM65 is that it can be field calibratable using standard gases and calibration equipment. So it's very much analogous to the standard reference station monitoring kit. It's also incredibly robust. It's temperature managed, and we've run it in temperatures as low as -40 degrees and as high as 50. Also with the AQM65, of course, there are field service requirements. So it requires filter changes and it also requires flow rate checks. Another product in our fleet, which is similar to the AQM65, is the Dust Plus Gas Sentry. Some of you may know it as the AQS1. The Dust Plus Gas Sentry has a smaller set of available sensors. It can measure ozone, measure NO2, it can measure VOCs. It also measures PM10 or PM2.5. The AQS1 can also be field calibrated using standard calibration cylinders, ozone generator, and calibration system. It also requires filter changes, and it also requires flow rate checks at the field by the instrument. But the measurements are very robust. So the Dust Plus Gas Sentry was designed with the construction, demolition, mining sector as an application. So it's very robust, and the nephelometer engine can cope with a high particle loading. The AQY is a very different product. The AQY is a fixed sensor configuration. So for now, it's not a customizable sensor configuration. It comes with ozone, NO2, PM10 and PM2.5, temperature RH, and dew point. This at the moment is not configurable, but the key feature with the AQY is that it doesn't require any field servicing, so there are no filters that need to be changed, and it's not calibrated using standard calibration gas cylinders or calibration equipment. The calibration methodology for the AQY is what's known as a co-location calibration, which we'll get onto a little bit later in the presentation. The kinds of applications that we're targeting for the AQY is the smart city application. One project which we're incredibly proud of is our 100 AQY network, which is currently still underway in LA. We have a blog about this network on our website. I'd encourage you guys to head over there and have a look. The data that we've been getting back from our 100 node network has been fantastic. It's enabled us to generate an incredibly rich data set, looking at ozone transport across the city, looking at NO2 transport across the city. Once you get a certain density of monitoring, we can start to generate heat maps and get a really fantastic idea of what's been happening with the air quality at a very high spatial resolution. So this is one particular application we have in mind for the AQY. Other applications include monitoring around schools and hospitals. We do have some AQYs in the construction sector. We're still learning a little bit about how long the AQY will last under those harsh conditions. So please check back on our website about some of the growing applications for the AQY product. Okay, where are we? So just to recap, the AQY has a fixed sensor configuration for now. Later on in the webinar, we'd be really keen to hear from all of you about what additional sensors, measurement parameters that you would like to see come through in the AQY package. But just to remind you that the AQY comes fixed with ozone, nitrogen dioxide, PM2.5, PM10, temperature, relative humidity, and dew point. So we'll have a quick discussion now a little bit about the actual product itself and how the instrument is constructed. So I'll just pop an image up on screen that shows you where the various measurements are made from. All of the sensors with the AQY protrude out from the bottom face of the AQY. The ozone sensor and the NO2 sensor and the PM sensor inlet are all on the bottom face. The AQY can be made to stand up. The front panel has a small vent to allow air to circulate because, of course, we draw air in to measure. And the AQY is powered with a 12-volt DC power point. I'll ask Andrew if he can to flick over to the product camera, and I'll just show you in a live shot exactly the same thing that we were looking at in the PowerPoint presentation. So here we have the ozone sensor inlet. Here we have the NO2 sensor inlet. This is the temperature RH sensor here. This is our PM sensor, and this is our 12-volt input. If we have a little look inside the AQY, we can see here that the sensor cartridge, the ozone and the NO2 sensor cartridge comes on a single PCB. This, in fact, is a serviceable part. We can talk a little bit about this later on. And the PM sensor, I've got another example of the PM sensor here. This is also a serviceable part. So part of the service philosophy behind the AQY is that rather than performing servicing on-site at the field, you would be expected to simply swap out an entire AQY, bring that AQY back to your laboratory or your workshop, and then you can replace these sensor cartridges and these PM cartridges, and we sell those as consumable parts for the AQY. Okay, we'll just flick on to the next slide. The next slide just shows graphically a little bit about what we were just talking about. So we have two serviceable components, just two. One of the serviceable components is the sensor cartridge. The sensor cartridge is an ozone sensor and an NO2 sensor combined. This sensor cartridge is calibrated at the Aeroqual factory. We can talk a little bit about that later on in the webinar. And also another separate serviceable component is the replaceable PM sensor. And that's fairly easy for anyone to do in a workshop. You just have to be in a clean environment. It's pretty straightforward, and it keeps your field servicing time down to a minimum because you're not doing any work on the actual instrument. The idea would be that you might have a network of 10 to 15 AQYs, and at any given time you might have 2 or 3 AQYs in your workshop and some replacement sensors. As an AQY requires replacement, you would replace the entire AQY in the field, and then you would bring the AQY back to your workshop and perform the sensor replacement in a clean space. So that's roughly the service model. Many of you might be wondering, excuse me, what the sensor lifetime might be. We're still learning a little bit about the various sensor lifetimes under different environments. Just to remind you again that if we have a look at the bottom of the AQY, the front surface of the NO2 sensor is simply exposed to the outdoor environment, and so too is the ozone sensor. We have a small stainless steel mesh over the ozone sensor, but the NO2 sensor is exposed to the environment, and there's no filtration, of course, put in front of the PM sensor before it's measured. This is done, of course, to reduce the amount of field servicing, but it does accelerate a little bit the end of life of the various sensors, and we're still learning a little bit about what that lifetime is. Our observations so far have been that in clean environments, the sensor lifetimes can last upwards of 10 to 14 months. But we believe that as we move into more harsher environments, especially where the PM, the particle loading, is very high, places like India, Beijing, we expect that the sensor lifetime may be reduced a little bit. We're certainly seeing this in some harsh conditions. And this may also be true if we are applying the AQY as a measurement instrument into, say, the construction or the demolition industry. We really would not expect the sensor lifetime to be as good under those conditions. So we're still learning, but this gives you a rough idea of what kind of sensor lifetimes to expect. And just to remind you again that the service philosophy behind the AQY is that the field time is kept to a minimum, and that we simply bring in the entire AQY and we swap it for another AQY in the field. And all of that service is done in your laboratory back at your office. Okay, the next slide. We'll just talk a little bit about some of the mounting requirements for the AQY. The AQY, of course, is incredibly light. I think it weighs around about 1 kilo. So the AQY comes with a simple mounting bracket. On the back, the mounting bracket can be installed in a horizontal position, or it can be installed in a vertical position. The next slide shows you a couple of different installation solutions that some of our customers have come up with. On the left-hand image from our customer Quandary Consultants in Denver, Colorado, you can see that the AQY has been placed on a pole with the mounting bracket in the vertical position, and just two very strong stainless steel cable ties have been used to mount that AQY to the pole. Same thing is true for our customer J.J. Wilbur in Vermont, has managed to mount the AQY against a tree in New York. While we're talking a little bit about some of the mounting requirements, we can also talk a little bit about some of the power requirements for the AQY. The AQY itself is run on 12 volts DC. When you purchase the AQY, you'll get given a power plug pack for your country. The current draw ranges from about 1.5 to 2 amps, and this does depend a little bit upon the distance the AQY is to a cell tower. So inside the AQY, every AQY comes with a cellular modem. If I just get Andrew to flick back to the product, the cellular modem is installed here, and the cellular modem takes a standard data SIM. Andrew, is the sound working? Yeah. So the AQY comes with a cellular modem. You can we have most of our AQYs in the US at least running on the AT&T network. It seems to be pretty robust. But depending on the distance of the AQY to the nearby cell tower, if there's some distance, it seems that the modem can draw a little bit more current, and then this can increase the current demand. Our customer, Quandary Consultants in Colorado, is successfully running a network of 4 AQMs on solar panels. And we have some rough calculations for you around what kind of battery that you might need and how long you might get your runtime out of a given battery. Approximately a 20 amp hour battery will run your AQY for about 1 day. But if you want to get a higher runtime, say upwards of a week, then you may need to invest in a larger battery pack, maybe 100 to 120 amp hours. We are working hard on trying to reduce the power consumption as much as possible. We know that it's a valuable feature to have the instrument run in low power. A lot of our AQYs in the field at the moment are able to tap into mains power, so they don't have these low power requirements, but there's another large sector of applications which do. So perhaps in the chat, as you guys are listening to me, if you could just type in whether or not having low power or battery powering is really important to you, then we can gather up those comments and we can use those to help us influence our product development in the future. So just let us know in the chat how important it is to you to be able to run the AQY on a battery. Okay, Andrew, next slide. So those of you who are familiar with our AQM65 product will know that it comes with thermal management system. We've run our AQM65 in places like Fairbanks, Alaska, in Mongolia, in Russia, Kazakhstan, lots of places, northern China, where it gets very cold. The AQM can withstand temperatures as low as -40 with that internal management system. However, our AQY has no thermal management, so we're still learning a little bit about what kinds of temperature extremes the AQY can actually withstand. However, we were really pleasantly surprised to learn from Dr. Jeff Masters, who is the founder of Weather Underground, who reviewed our AQY on his website. Jeff said that the AQY1 has been operating at temperatures as low as -26 degrees Celsius with no problem. So we at least know that we can get good performance from the AQY down to those temperatures. We were really happy to learn that. Jeff's blog is over at Weather Underground, so we'd encourage you guys to go and have a look at that independent review. We also have AQYs running in the Middle East, in Dubai, at elevated temperatures, and we're still learning about what prolonged exposure to very high temperatures and very high humidities is going to do for the AQY. Our expectation is that it may simply just reduce the sensor lifetime a little bit, which means that you'll be exchanging your sensor cartridge a little bit quicker, possibly under those extreme weather conditions compared to more mild conditions. Okay, so I'm on to the next slide, Andrew. So we're just, I'm not going to dwell too much about the Aeroqual software. Many of you, hopefully, will be familiar with our existing software platform, Aeroqual Connect and Aeroqual Cloud. Exactly the same software platform is used to drive the AQY. Our Aeroqual Connect software is software which is running on board the local AQY. So the AQY has an onboard web server. It has onboard data logging. All the data is stored on onboard memory. There's enough storage capacity on there, I think, to last about 5 to 10 years. So there's no urgency to download the data quickly. The software on board allows you to connect directly to the instrument using your laptop or using your cell phone, exactly the same way as you would connect to the AQM or connect to the dust monitors. The onboard software allows you to graph out visually in a time series graph. It also allows you to upload any calibration parameters you may wish to upload, and the software also has a service log which will allow you to enter in details if you were to change out the sensor cartridge or the PM. However, with the AQY, because our intended application are large networks, it's far more likely that you'll be using our cloud software in order to manage your network of AQYs. This is really easy because the AQY comes with a cellular modem. You just have to supply the SIM card. I think I have a slide a little bit later which discusses some of the data rates or some of the data usage. The cloud software allows you to connect to all of your AQYs in one go. The graph on the lower left-hand side there shows approximately 5 or 10 AQYs, and you're able to look at the ozone values from your network or the NO2 values from your network. And we also have some mapping features which allows you to place all of your individual instruments on a map. So with a product like the AQY, which is a network product, the cloud features are incredibly powerful and incredibly valuable. And most of all, the most valuable feature, I think, for you as a customer utilizing our cloud software is that the Aeroqual service team can help you troubleshoot your instrument. So if your instruments are connected to our cloud server, myself, Andrew, the service team are able to see that data. We can jump on and talk you through any issues. So I'd really encourage you guys to always connect your AQY to our cloud server in order to give you access to your own data and, of course, access to our service team too. The AQY comes with a software package or a combined software and service package called Aeroqual Care. Aeroqual Care includes the cloud software subscription. So that's your subscription to Aeroqual Cloud, which allows all of your data to be stored in our cloud server and allows all of those networking features. It also provides some discounting on spare parts. And it also includes basically access to the service team whenever you need it. So currently the AQY is bundled together with all of that. So when you purchase the AQY, you'll receive the Aeroqual Care package. You can learn a little bit more about the Aeroqual Care package by heading on over to our website. But for now, we're bundling it all together, so there's not a lot of decision making that needs to occur when you purchase the AQY. It comes with the software bundled. Okay, so some of you might be interested to know what kind of data communication demands are placed on the AQY. To be honest, it's a really difficult question to answer because we observe a really large range of data communication usage depending upon which telecommunication provider people are using. We're fairly confident in the amount of data usage that our instrument requires, but we find that whether you're with AT&T or Sprint Mobile or Vodafone or Telecom, the telecommunications provider sometimes can manage those data bundles a little bit differently, and inevitably it looks as if the data usage goes up compared to what it should be for the AQY. So to be safe, we would recommend subscribing to a data package of about 1 gigabyte per month. That seems a little bit high. In most cases, we observe a few hundred megabytes per month usage. Cases where the data usage can go up, we've observed, is if the data communication is not very good, the signal strength is not very good, and the modem tries to continuously connect to the network, and in trying to connect to the network, it can use up data. So in cases where the data connection is weak, sometimes you get a spike in data usage. Remember, however, that all of the data from your AQY is stored locally on board the instrument. So if you lose that data connection, then all of the data will continue to store locally. So for example, if your data connection goes down for a few days and is then restored, that's no problem. All of the local data that's stored on board the AQY will simply backfill into our cloud database. So there's no issue around loss of data if you have a loss of connection. Of course, you'll just lose that real-time connection. There's a section of the software in the configure part which allows you to see the signal strength. This is a key health indicator for your cellular modem. Our observation so far is that an AQY which is able to maintain a connection strength of between -50 to -60 decibels usually maintains a really robust, reliable connection. If that signal strength begins to drop off down to say -90, then we begin to see quite regular connection dropouts as the modem is continually trying to reconnect to the cell tower. This is not a problem again for your data retention because all the data is retained on board the instrument. It just means that you may lose that real-time connection, and it can result in an increase in data charges because each time the modem tries to connect to the cell tower, you get charged for that data connection, even though you're not actually sending data. So this is why we can see that range of data charges. If your AQY is consistently having these kinds of data connection issues, then we might think about trying to release potentially a stronger antenna for the AQY, or we might have to encourage you to perhaps reorientate or shift the mounting location of your AQY to a better position. Just a reminder about the connection options that you have available with your AQY. The AQY does have a Wi-Fi chip on board. This Wi-Fi chip or Wi-Fi functionality can work in two different ways. The AQY can be set up as what we call a Wi-Fi access point, which means that it's broadcasting a Wi-Fi network. That means if you approach the AQY with your cell phone or your laptop, you can see the AQY as a Wi-Fi network, and that will allow a service engineer or technician to download data onto their laptop. But another option, another way to utilize the Wi-Fi chip is to put the AQY into client mode, which means it's looking for a Wi-Fi network to latch onto so that it has access to the internet. And so if you are running your AQYs in a city where you have lots of potentially municipal Wi-Fi hotspots available, then you can actually latch onto that municipal Wi-Fi hotspot, and you can get your AQY onto the internet for free if the city allows it, or if the Wi-Fi provider allows it. So that's another option of getting your AQY onto the internet if you have the installation nearby a Wi-Fi access point. Okay, so I'm going to shift focus a little bit now and talk more about the actual measurements themselves, what kind of performance that we are currently observing with our sensors, and some of the ways that you as a customer can validate your measurement, how that's done, and how Aeroqual was trying to compensate for some of those environmental impacts that you may hear about sensors being susceptible to. So the AQY measurement parameters, once more, are ozone, NO2, PM. Those of you who already own an AQY, you may have seen in the sensor configuration table quite a few more measurement parameters. So for instance, you may have seen parameters such as O3 raw or PM10 raw. So this raw measurement is the measurement that we obtain directly from the sensor without any kind of compensation for environmental effects. And in order to realize the increased performance, Aeroqual's deep history in knowing about how sensors behave, both our own sensor and third-party sensors, we are able to characterize the sensor's interference to temperature, humidity, and other gases, and apply some onboard correction algorithms. So this is why you can see the raw measurement configuration in the sensor list. So in your configured sensor list, you may see a sensor called OX. OX is a sensor which is an electrochemical sensor, which is sensitive to both NO2, but also a little bit cross-sensitive to ozone. The NO2 sensor is the corrected, or rather the calculated NO2 concentration. So in order to get high accuracy NO2 measurements, we take our ozone sensor, our accurate, robust ozone sensor measurement, and we use that ozone sensor measurement to correct for interferences on the NO2 sensor. Electrochemical NO2 sensors and electrochemical ozone sensors are very cross-sensitive to each other. So it means that an electrochemical NO2 sensor is quite cross-sensitive to ozone, and electrochemical ozone sensors are quite cross-sensitive to NO2. So it's very difficult to get an accurate measurement just off the sensor itself. But the Aeroqual ozone sensor, the gas-sensitive semiconductor sensor, is incredibly specific to ozone. You can feed large amounts of NO2 gas to our ozone sensor and it doesn't respond. And also our ozone sensor is pretty robust as well against fluctuations in temperature and humidity, although it has a small interference. So this is why you can see ozone raw and ozone on your sensor list. So we correct a little bit for the environmental impacts on the ozone sensor, and then we use that very robust measurement to correct for the interference on the NO2 sensor. Also, particle measurements, as you probably well know, are also somewhat sensitive to fluctuating humidity. So because we're measuring temperature and humidity, we can also apply some correction algorithms to those and obtain a much more accurate measurement. It's really important to stress that these corrections are done on board the instrument and they're done in real time. They're not done historically and they're not done in the cloud. So this means that the correction algorithms are fairly reliable. We don't gather data, send it to our cloud database, and then apply the correction algorithms later. It's all done on board, and you can always access the raw data, or rather you can access the corrected data off the instrument locally if you prefer to do it that way rather than taking it from our cloud database. Okay, if you head on over to our website, you can see the published sensor specifications. So you can see that for example, the particle sensor, the PM2.5 and the PM10, the range is about 0 to 1,000, which is more than you'd need for a smart city network. And the accuracy is plus or minus 10 micrograms, and they're quite sensitive as well. So our lower detection limits are down around about 1 microgram. And also you can see the sensor performance specifications for ozone and the calculated NO2. If you just head on over to the website, you can get a much more detailed look at the published performance specifications. So a little bit about how Aeroqual validates the sensor performance at the factory where we are. I've just put up a couple of photographs on the screen to show you the kinds of infrastructure that we have here at the factory in New Zealand. We use standard calibration reference gas cylinders and standard reference equipment analyzers, chemiluminescent analyzers and photometry analyzers to calibrate our sensor cartridges. So the way that we perform the calibration here is that we have a calibration chamber. It's about 3 cubic meters, so quite large. You can see an image of the calibration chamber on your screen on the right hand side. We would fill up the calibration chamber with our NO2 and ozone sensor cartridges. These are the serviceable part that we can provide you. And then we fill the chamber up with a known concentration of ozone or a known concentration of NO2. That concentration of ozone and NO2 is monitored using standard reference equipment, so we can be very confident in that concentration. And then we apply calibration algorithms, offsets and gains to our NO2 and our ozone sensor. And so that's how we factory calibrate the AQY, and we apply a very similar process to the PM sensor as well. So your AQY will arrive from Aeroqual factory calibrated. As a user, there are other ways which you can validate for yourself whether or not the calibration has transferred well from the Aeroqual calibration to your field. We encourage you to, those of you who are thinking of buying AQYs or already have these AQYs, to engage with your local municipal governments who run reference monitoring stations, because by far and away the most robust and the most reliable and the most defensible way to validate your data is to co-locate the AQY next to a reference monitoring station. So on the screen here we have a couple of photographs. On the left-hand side is an image taken by our customer, Texas A&M Transport. There they installed 12 AQYs, all in the same location, right next to a municipal monitoring station. Again, these municipal traditional reference stations are large, are very large systems. Often they're put inside a shipping container. They have traditional chemiluminescence analyzers for NO2 and photometers for ozone and TOMs or BAMs for particles. We would typically recommend that you co-locate your AQYs next to the reference sites for approximately 1 week. 2 weeks is even better. We would normally run the AQYs for 3 to 4 days initially to gather up some data. We would then compare the data from the AQY to the data to the reference station, and we can again apply some offsets and gains to further refine the Aeroqual factory calibration. So on the next slide, you can see a really simple example of how that might be done. This is just one AQY compared to a reference station. You can see on the left-hand side of the plot, for about 5 days, we gathered ozone data from the reference station and ozone data from the AQY. You can see in this particular case that in blue, is the reference station data, and in red is the AQY data. The Aeroqual AQY was reading a little bit under the reference station for those 5 days, but with that rich data set from the field calibration, we can then apply a gain and offset to the ozone channel through the Aeroqual software, and then we run the AQY again for a few days with the new offsets and gains applied, and you can see that we get a much better fit. So this is the most robust, recommended, defensible way for you to validate and be confident in your data. So I'd really encourage all of you who are thinking of getting into the smart city air quality monitoring business, form partnerships with your local municipal air quality monitoring station organizations, and use those reference station data to validate and calibrate your AQYs. Okay, so I'm going to talk a little bit about air quality sensor performance, or rather the South Coast Air Quality Sensor Performance Program. I'm sure that many of you are familiar with this program. This organization has done incredibly good work evaluating the performance of a number of low-cost air quality monitoring stations or low-cost monitoring equipment, including our AQY. The organization doesn't make any recommendations. They just do a very robust performance test and publish the data online. It's quite a nerve-wracking experience for those of us in the manufacturing business, because we hand our instruments over to the performance evaluation center and we just have to hope that everything goes well and that we get a good result. But Aeroqual, our sensor team here and our product development team were really happy with the results that we got from the AQSpec performance. You can download the performance evaluation from their website, but I'll just give you a couple of key features or a couple of highlights from the report. Our ozone sensors performed really well over a period of about 3 months. Some key comments that came out of the report were that the AQY ozone measurement showed an excellent correlation with the corresponding FEM data. FEM, of course, stands for Federal Equivalence Method. So we obtained an R-squared of about 96, which is a fantastic correlation. And our AQI and O2 measurements performed almost as good. We had retained an R-squared value of nearly 0.8 across that time period. And we scored similarly for the PM 2.5. So please head on over to the AQSpec website and have a look for yourself and completely independent performance evaluation of our AQY. Okay, so this is where we start to turn over to you guys to hear a little bit about maybe what you would like for the future for the Aeroqual AQY. For now, we've chosen ozone, NO2, and PM 2.5 and PM 10 temperature RH as the key measurement parameters because we think that these are in highest demand. Especially from inner city air quality monitoring from an air quality perspective. But what would you like to see? So please type into the chat, tell us a little bit about maybe the kinds of additional measurement parameters that you guys would like to see. We're gathering up information from the field about what people want. Some people have told us that they would like to see carbon monoxide included. Other people have told us that they would like to see a VOC sensor, PID sensor included. Some people have asked us about indoor air quality monitoring using the AQY. Of course, the AQY could be used for an indoor air quality monitoring application. You don't tend to see so much ozone in an indoor application. Indoor monitoring tends to be a CO2 problem, CO2 and PM. So if you think that there's a good future for indoor air quality monitoring with the AQY, let us know. You can pop your suggestions into the chat, or of course, please write to us at sales@aeroqual.com or technical@aeroqual.com if you have any suggestions for future measurements. For now, we're not including weather or noise in the AQY package, but we're very keen to hear from you whether or not. So some of you have asked about PM1. Maybe at the moment the sensor we integrate outputs PM10 and PM 2.5. PM1 is a very specialist measurement application. We have had some request for it. It might be something that we look into the future. So thank you for that. No plans for PM1 at this stage, but it has been added to the list. People have said carbon monoxide, so that's cool because we've had that request in the past. So carbon monoxide you may well see an AQY with a carbon monoxide sensor in the near future. NOx and VOC, thanks Ibrahim, of course. It's good to see you. Good to see you, Ibrahim. I can't see you, but it's good to see you. Absolutely. So CO, NOx, and VOC. It's really, really difficult from a manufacturing perspective to make an incredibly small AQM65, which I guess is kind of what a lot of you might think the AQY is. So we're not sure at this stage whether or not we will have an AQY with 6 measurement parameters or whether or not we might have different options of AQY, each one with a few targeted parameters. But of course, those standard roadside measurement parameters like NOx and PID, I think we'll definitely see an AQY with these in the future. Okay, so I've gathered up some of those comments. Thanks, guys. Please do write into us again, sales@aeroqual.com or technical@aeroqual.com. Or if you'd like to write to me, john.wagner@aeroqual.com. And we just want to gather up as much information as we can and as many recommendations as we can about what it is that you guys would like to see in the future. In addition to the future and measurement parameters, we're also kind of interested to hear about what kinds of future communication protocols that you guys have heard about that you think are going to be useful. Some of the upcoming Internet of Things communication protocols include LoRa. Sigfox is another communication protocol. These are all lower cost communication protocols. They're not cellular based, but there's also a balance with bandwidth data communication. So we're just learning about this stuff. And Bluetooth is another potential option. But if any of you are beginning to see trends towards particular IoT internet data transfer protocols, let us know, and we'll make sure that we keep our development team on their toes so that we can meet any of these potential future demands. For now, though, the data communication protocols remain cellular and Wi-Fi. But again, let us know, because we want to make sure that we can keep track of what people are using. Okay, we're about to flick over to the one slide that I'm sure you've all been waiting for patiently. Carl Beck, our VP of marketing, has allowed me to put a slide up on pricing. So here it is. The price of the AQY is volume dependent, but the current price point is about $3,000 to $4,000 US. If you guys are interested in understanding a little bit more about local distribution, volume pricing, or whether or not you have a local distributor, just email sales@aeroqual.com, and you'll be put in touch with one of our local sales guys, and you can learn a little bit more about what it's going to how you can obtain an AQY. All right, guys. I'm trying to grow our YouTube channel as much as possible. So when it comes to technical information, I'm trying to put as much content on our YouTube channel as I can. We'll always maintain user guides for our products, our AQMs, our dust sentry, our AQY. But there's already a playlist on our YouTube channel for the AQY for some software recommendations and a little bit about installation. So do head over to our YouTube channel, like and subscribe and all that kind of stuff. I'm supposed to say that. So we'd love to see you over there. I will check the comments in the YouTube channels occasionally, so if you want to post a question there, do so. If not, you can always write to technical@aeroqual.com or john.wagner@aeroqual.com. There's a little bit more information about the AQY on our main website as well, on the product page. Over there you can download the user guide, you can download a spec sheet. So if you wanted to read up a little bit more about the product and some of the applications, head on over to the website. You'll find a little bit more information about the AQY over there. All right. So this is the time of the webinar where I keep an eye on the chat and we hear from you guys if you have any questions. So please do post some questions in the chat. Andrew O'Brien, my director, producer, driver of this webinar, I'm assuming has been keeping an eye on the chat and may have some questions that he wants to hand to me. If not,
I don't think I can find that grouping.
Right, so some people have asked about installation height. This is a really, really clever question. It's a balance between accessibility and keeping the AQY safe. So of course, ideally, the AQY would be installed at breathing height, so 1.5 meters off the ground. Of course, that's not particularly safe. An instrument like the AQY, which is 1.5 meters off the ground, can easily be taken down by somebody else. Also, you do need to consider accessibility for yourselves, for service technicians and engineers. If you install the AQY too high, 10 or 15 meters above the ground, you might need to get a truck or a crane in order to remove it. So the ideal height, I think, is a height that's too high for anyone to steal, but not so high that you can't replace it with a ladder yourself. So this is really a case of balancing between security and accessibility, and everyone will have to come up with their own solution for that. Certainly, though, mounting it 3 or 4 meters off the ground is perfectly fine.
Pests in the instrument, or spiders at the inlet?
Right. Somebody's asked questions about do you ever get any spiders or creatures inside the AQY? Not so far. We have a very small vent. If Andrew just flicks over to the product camera, we have a very small vent here. This is to allow the air to come out. We have had problems with spiders and geckos and other such animals crawling into the AQM. So far, we haven't had too many problems with the AQY. It's very difficult to fight nature. So, of course, if you happen to be in an environment where you have a lot of creepy crawlies, spiders and things, it's just going to have to form part of your own service procedure to keep an eye on that. I would say the bigger concern, rather than spiders getting inside the AQY, would be some kind of interference with the PM inlet. So there's no filter on the PM inlet. So if you do get some kind of spider web or some kind of infestation on the PM, that is going to impact significantly in your PM data. So that is something that's worth keeping an eye on. A common question I'm seeing in the chat and also is around approvals, international approvals like TÜV, EPA. It's really, really early days at the moment in the low-cost air quality sensor market. It's really important to note that at this stage, there really isn't available a certification pathway for a lot of these low-cost sensor products. That's not to say that there won't be in the future. Both the European certification agencies and the American certification agencies have both said that they will, in the near-term future, release certification options for low-cost sensor instruments. In fact, Dr. Jeff Henshaw is deeply involved in this process, and he is one of a number of advisors on some of these committees who are advising on sensor performance targets. I'd really advise you to keep an eye on the EPA website and on the EEA website for up-and-coming sensor performance standards and sensor performance certification pathways. Aeroqual will certainly be deeply involved in that process once those certification bodies release those performance specs. Someone's asked about a mobile version. I would say that the AQY is pretty mobile as it is. You just need to obviously power it. It doesn't yet come with a GPS tracker. That could be something else that we may well consider. If you'd like to see live GPS tracking on an AQY, please let us know. That might be something that we can develop. But if you'd like to use the AQY in a mobile application, that's a really interesting challenge. Just remember that the measurement frequency is about 1 measurement per minute. That's to do with how the ozone sensor cycles. And so if your truck or your bicycle is moving too quickly, then your spatial resolution may not be so great if you have a mobile application. So that's just something to consider. But I think the instrument is about as mobile as it can get, as long as you apply a battery. How do you know when to replace the sensor? So what kind of indication would you have that it's time to replace the sensor? The instrument has some onboard diagnostics, so we can detect sensor aging, and that would be reported to you through the software. So that's one way. But the best way to know how to replace the sensor is just to keep an eye on your data. Data patterns, diurnal data patterns and weekly data patterns tend to be quite repeatable. So please keep an eye on your data, and if you start to see significant changes in behavior in the data, that's one indication that the sensor cartridge may need to be replaced. And of course, please reach out to us, the Aeroqual service and maintenance team, and we'll certainly help you understand what kind of sensor cartridge replacement frequency that you may need. Okay, so I see that we're getting near to the end of the time of the webinar now. Thanks to all of you who signed in. Once again, please write to us and tell us what you're interested in and what you need. Sales at aeroqual.com or technical at aeroqual.com. Those of you who know me well, write to me, john.wagner at aeroqual.com. We're keen to hear from you about what you need. This webinar will be posted to YouTube, so you can play it back, and we're going to do another session, I think, in a couple of days' time for perhaps some of our overseas colleagues who aren't able to sit in on this session. So thanks, guys. Thanks for coming. It was a really exciting experience for me. I've never done this before. I hope it went well. I hope you guys learned something, and please do get in touch with us. And for now, goodbye and take care.